6.2.1 is on dilations. So the review should have been done in class. So we're going to move on to 6-42. How do you think the shape will change when both x and y coordinates are multiplied by a number? Use the directions below to help you answer this question. What you're going to do is you're going to plot the points and connect them to make a quadrilateral. Then you'll multiply each coordinate by 2 and connect those points to make a new quadrilateral. So right now, begin by graphing these points right here on your graph. Then you're going to multiply the x and the y by 2 to get your new coordinates. Then you're going to graph those new points on your graph. Don't worry about coloring anything right now. What we want to do is we just want to look at your original quadrilateral and your new quadrilateral. Now that you've completed this work, your coordinates should be here, 4, 2, 6, 2, 10, 10, and 4, 10. Notice that my original quadrilateral is the red one. My new quadrilateral is the blue one. This is called a dilation. When you look at the two figures that you graphed, when you transform a graph shape by multiplying each coordinate by the same number, that is called a dilation. We've looked at this before when we talked about scaling, like with Scale Ella, making things smaller, shrinking them down, or making them larger, okay, making them bigger. So what we want to look at is how do the side lengths of the new shape compare to the original, and how do the angles of the new shape compare to the original? To do that, we're going to just take a look at the shapes. And what I can do is I can take my original and I can move it on to the new one, just like that. And if you look at, for example, the sides, the bottom of the red one is 1 unit long. The blue one is 2 units long. And so what happened is it doubled, it went from 1 to 2. You could also do the same with looking at the height. If I look at my red quadrilateral, it's 4 units tall. My blue quadrilateral is 8 units tall. And so what happened was all of the side lengths doubled. We can also look at that with the top side. This length is 3 for the blue one. The top side is 6. Again, it doubled. So all the side lengths are going to double. And we can also do the same. We can look at the angles. So if I just match up the angles, notice that the bottom left corner right here, for both of them, is a right angle. So that's a 90-degree angle, so they're the same. I can also drag the red one onto the blue one. Notice the upper left corner is also a right angle. And if I continue to drag this over here, notice that the angles do match up. They are the same angles. And I can just move this around and take a look at that and see how they do match up. So when we're answering these questions right here, we can talk about the side lengths. The side lengths of the new shape are twice as long because everything was multiplied by 2. The angles, however, are the same. They did not change. And remember, the word is corresponding angles. The corresponding angles are the same. The corresponding sides are twice as long in the new shape. Now let's take a look at the next one, 6-43. What I want you to do here, again, you're going to graph these points oh sorry, it's already been graphed for you. So you're not going to graph those, it's already been graphed. But now what I want you to do is multiply all of the x and y coordinates by 1/2. So just take half of the numbers. So for example, for the first one, half of 6 is 3. Half of -4 is -2. And what you'll do over on the graph is you'll graph that, go over 3, down 2, and put a point on your graph. That's your new point. Continue to do that for the rest of those coordinates and graph it. So now that you've completed that, this is your new figure. Now we want to talk about what happened. Again, if we take a look at the angles, I can line these up and notice that these angles match up. We can do that up here as well. Notice that the angles are the same, and I can drag it down here and notice again that the angles are the same. Now what about the side lengths? So the original was the black triangle there. Let's take a look at the sides to see how they compare. So the easiest one to do would be to look at the bottom. And then if I look at the black triangle, the bottom is 8 units long. If I look at the red triangle, the bottom is 4 units long. So it looks like the new red triangle is half the length of the original, the black triangle. So when we look at what happened, the side lengths are half as long, but the angles are the same. So all of the angles are the same, but the side lengths were cut in half. What happens when you multiply everything by 1? Well, let's take a look at that. Let's say I had the coordinate 2, 5. If I multiply everything by 1, it's 2 times 1 and 2 times 5, which really just gives me 2, 5. So everything stays the same. And the word for that is congruent. Congruent means it's exactly the same shape and figure. Everything's the same. So multiplying by 1 doesn't change anything. It's the same. Now, for part C. So this is our last one. What I want you to do is take a look at the xy again. It's been graphed for you, those points. Now we're going to multiply every coordinate by -1. So for example, for the first set of points, 6 times -1 is -6. -4 times -1 is +4. So go ahead, write down the coordinates, and then you're going to graph those coordinates onto your graph. So once you've graphed this, this is what it looks like. The red triangle is your new triangle. The coordinates are right here. We want to talk about what happened. So this one's a little bit more difficult to understand. You might be able to look at it and notice that it's flipped upside down. So maybe it's either a rotate or a flip. Well, I can show you by, we can use some of these tools. This one says flip horizontally. So if I flip the red one horizontally, that's what happens. So it doesn't really look like that worked. So I can go back and we can flip it vertically. And so it looks like flipping it has caused it to look the same, except for the last thing I need to do, it looks like I need to move it up. And remember, that's called a translation. And so far we've flipped it, and then we can translate it or move it up. And notice how it lands directly on top of the original. And so what happened was triangle is flipped or reflected, and it was also translated. Remember, translated means that it just moves up or down, left or right. So when we multiply everything by -1, that's what happened. The triangle flipped or or reflected, and then it moved, so it was translated. So the next thing you're going to do, now that you're done with all your notes in the video, you're going to complete the practice for 6.2.1 and then have your teacher check it and turn it in.